Ira Miller, one of the dinosaurs of crypto. Wow, one of the early ones. We met in Buenos Aires in 2013, right? I think so.
Yeah,
at Rodolfo's conference. Yeah.
The first LaBitConf, or was it the second?
It was the first. I think we're both like long-term LaBitConfers, aren't we?
Definitely.
So,
yeah.
I hope you like it here.
LaBitConf is one of the best conferences in the space, and now UNCHAIN is definitely going to join this elite crew.
Thank you so much.
Thank you.
So, Ira, by the way, is building the new decentralized internet, and you tell us how.
Thank you for the introduction, Aaron. So yes, we're building a new peer-to-peer internet, decentralized internet. Actually, there's not even a word for what we're trying to do. It's broader than the internet. We want to encompass private networks, dark networks, simply private data, like the things you put on your computer that you don't actually publish. So it's a very ambitious plan. It will take a lot of time. But first, we should talk about what's wrong with the internet of today. And Peter Sunde, one of the co-founders of Pirate Bay, gave an interview a couple years ago where he said that we've lost the battle for the internet and that we should give up and go into damage control mode. And the reason he said this is because even though the internet was designed to be decentralized, everything we've built on it since then is centralizing and centralizing from the ISPs, so who actually routes all the data, to all the major data providers like Google and Facebook, and they manage all of your data for you. So, for instance, these are some problems with the current system. Because of these points of centralization, it's very easy to have censorship, and we see this very often. You have countries putting pressure on social media and so on to do censorship, like in China. You have identity theft, because you are not in control of your information. You're trusting these third parties, like Experian, the credit agency that just got hacked, lost 150 million people's identities. You do not really have a choice but to trust these people, and they are not really liable when they violate your trust. So ultimately, in the world, the internet of today, you are forced to give up your information to people who are going to lose it. You're going to have identity theft. It's pretty much inevitable. Same with fraud, privacy. These people own your data. Literally, Facebook owns your facial profile, your fingerprint. If you take a picture like that, they own this stuff. And fragmented authentication. So because you have to identify with each of these central silos of information, you have to create a new profile with each of them, give them your personal information so that they can then identify you, right? Some solutions, and by the way, this is not blockchain or cryptocurrency specific. We're talking about a whole set of tools, many of which already exist. Blockchains, however, do use public key cryptography, and this general set of tools is key to a peer-to-peer internet or any peer-to-peer tools. Encryption is very important. This is not really used in blockchains very much. Blockchains typically sign things so that everyone can see it and verify the signature, but they rarely encrypt things, which is to say hiding the contents so that only specific people can read it, with some notable exceptions. I noted that the Ripple team is working on secrets on a blockchain. Another thing that we would like to work on is an official keyring for your identity. So rather than sharing bits of private information with all these different silos and your identity being spread out over the web and controlled by other people, you should keep it yourself and keep your own keyring that you will then use to identify to all these other services. I'll skip over standards, it's very important, but basically, to summarize, we want to make everything peer-to-peer. That's what the internet should look like. That was the original vision of the internet. The TCP stack and many parts of the internet are designed with that in mind, and we've simply lost our way. So I'd like to introduce a new concept, the block tree. We call it a tree rather than a chain because it's not linear. Each person and distinct group has their own branch in an overall data structure called a DAG, a directed acyclic graph. These are coming into popularity across the space, but we've been working on this particular technology stack for over 3 years. And generally, the way you can think of it is that you have a branch where you would publish a new bit of data. Let's say it's a financial transaction, since it's familiar to all you blockchain people. You would send it to the recipient, the counterparty in the transaction, right? And then he would send that to one or more observers, right? These observers don't even need to know the content of the message. They just need to verify the hash, right? So what this observer is really saying is, I'm witnessing that event or transaction happened between sender and recipient at this time, and this is where it fits into sender's timeline, recipient's timeline, to avoid any double spends, that sort of thing. Now, one key difference here is that this is not explicitly for financial information. This event from sender and recipient, or participants in event, could be a contract, it could be a conversation, a tweet, it could be any kind of digital activity that these people would record and transmit. So we are just releasing a wallet application, which will be the first really user scalable access into our network. And the main thing that this wallet does is help you manage your identity. As I mentioned, keeping your own keyring is essential to, in my opinion, to this new internet vision. We chose to use PGP, pretty good privacy, for this keyring, because it's a very well supported and popular framework. So for example, every Bitcoin release is signed with PGP keys of the developers. Most people in this space, if you run a brokerage, an exchange, something like that, you will have set up PGP on your email. One famous example of this use case was the BitPay team was defrauded out of $1 million because their CFO sent an email to their CEO saying, send Bitcoin to this address. They were not using PGP, so they were not signing or encrypting the emails. So the CEO had no way of knowing that the email was legitimate. And in fact, he sent the money. After that, they made a policy. Everyone has to install PGP. Who here uses PGP, by the way? Show of hands. Good, so maybe a third of the room, yeah. Okay, so we made an application that mainly is a PGP keyring and helps you manage your identities and your different keys. So here we have an example of the generate form from our app. You can also import them. And at the moment, while we're in beta, we pair with one or more Git servers. Since our first few thousand users were all on GitHub, we decided to go with GitHub as a default. In the later version, the 1.0 version of this app, we'll integrate SSH, and it will go full P2P. So what else can you do with this wallet? It's a file system, so it has a simulated file system in your browser, which is uniform and controlled by our permissions and encryption and so on. When I say uniform, for instance, it even works on Windows, despite their numerous file system problems. It's also a multi-currency wallet, so you can send and receive or do other types of transactions like burn or register. Our native currency, Guld, which is how you register a name or a key on our network, but also other currencies. Finally, this is a keyless API for other applications, which is where these other currencies would come in. So we're trying to create a platform, a standard platform for these new peer-to-peer type relationships and services on the internet. And this API would enable other applications like Guld Games. This is our first example dApp. So we just released into beta our wallet, which manages your keys, the ledger, signing, that sort of thing. And this Guld Games that you see is currently in alpha, where it communicates to the other one, the main wallet app. Does not have access to your keys, does not have direct access to the files system or anything like that. It has to request to log in or sign something, encrypt something. If any of you have ever used MetaMask with Ethereum, this will be familiar with you. MetaMask is an Ethereum wallet and keyring sort of manager, and it has an API that other applications can talk to. So for example, there are decentralized exchanges, Radar Relay, EtherDelta, that do not, by requirement, manage your keys. They can simply talk to the MetaMask API and outsource all that difficult stuff. So we have the same sort of ecosystem model. There's one app which does very sensitive things that accesses the private keys, accesses the raw data, talks to the network for you. That app should be very, very carefully reviewed. It should be made by people who understand cryptography and secure coding, that sort of thing. Every app developer, however, every dApp developer should not need to have all those expertise. Most people making dApps or trying to do an ICO are not really trying to get to the deep parts of the technology. They just want to make a new user experience for this or that previously existing idea or business. In this case, a game, like a lottery. So we can generalize this, and we can think that in the new web, you can interact with it in a number of ways, but we would standardize these. So specifically, you're taking control of your identity and all of the data that you publish, and you are enforcing things like permissions through cryptography. So if you have a group, you have an app, let's say, that has a group of users that they need to see each other's information, but you want to keep it private from other people. You have them themselves encrypt it for the people in the group. Same sort of thing with signing and so on. And all of these activities would be managed by a primary node software, which could be this browser wallet app, which runs in any of the major operating systems. However, it's about 100 times slower. It could be some, I would call it a native app, because it has to be very deep into the system, but we're developing an operating system that will do these things at a very low level for your whole machine. But regardless, you interact with your file system, your keyring, various apps, and then this filters through the node software, which actually makes changes to the file system, makes changes to a ledger, encrypts, decrypts things, and gives you a pretty transparent user experience that's just like the normal web that you're used to dealing with. Again, this is very familiar for those of you who are used to MetaMask. One thing I would say is different about Guld from Ethereum or blockchains is that most blockchains, they start with a financial use case. It's not uncommon for people to use the term distributed ledger technology, things like that. And it's very ledger specific. Ledgers are linear serial bits of data. But all the things that you do on the internet are not so linear and not so compact. So trying to strap on things like a file system onto Ethereum or another blockchain does not really work very well. They neither have the bandwidth for all of the little messages that would go back and forth, or for the very large messages like a video, nor do they have the ultimate scalability, because all of these things have to be stored perpetually. The blockchain would just grow and grow. Ethereum is looking at addressing this solution, or this problem, finally, after growing to over a terabyte on their blockchain, through sharding. So basically, they're taking their chain and they're breaking it apart into branches. However, after the fact, after you've got $50-some billion worth and thousands of projects on your platform, that kind of fundamental change of the data structure, security model, everything is quite challenging. So we started out with that concept years ago, and we've been developing towards how can we create a naturally branching structure and still have consensus and the kind of cryptography and trustless behavior that people in this sector expect. So basically, you can think of Guld as Ethereum post-shard, but designed that way from the beginning. Thank you for listening. You can find us on Telegram and see the source code for our app, operating system, various other things in our GitHub account. And I encourage you to follow our accounts, ask us questions, and I'll take your questions now. No questions? Yeah.
In the DAG graph, so how does, there was like a break after the first, from the bottom up there was a break. Does that represent, I guess, someone, you can like spin up a new community in a way and they can like enter the branching chain if enough people enable them, or is that break meant to be that like they're a completely new group that's deciding we're going to enter the system, and like even if it's doesn't affect anyone else, like are they allowed to? Are they on their own branch graph from the beginning eventually?
That's a very good question. DAGs are different from blockchains in the sense that they are made for forking and ultimately recombining. So you could have any number of scenarios. You could have a situation where two branches started out relatively separate. They actually all start from a seed template, but they would be separate, never having interacted before. And then when they first contract or transact, then they would have a point where they agree, a single hash of consensus. And if they joined a group, started playing games or corresponding together, the consensus, the ties between them would grow. And they would, in fact, be observing and validating more and more of each other's chains and transactions activities. The model that we have is that each individual and group gets its own namespace, its own branch, which you have to register, which is where the demand for our currency comes from. You have to burn Guld to get a name to be able to transact or correspond with other people on the network. You can also create group branches, which do not have a key that controls them, but a consensus algorithm, which you can completely customize. So you could make a group that's a direct democracy. Each key gets one vote. You could make a group like Guld itself is a meritocracy. So you have to fulfill certain requirements to do peer-reviewed work to get a vote or many votes. And you can customize any kind of consensus mechanism you want to reconcile the different opinions and signatures that people would make in the group.
Thanks.
Good question. Matthias?
Me again. I'm having
Keep it short, okay?
Yeah, sure, of course. I'm having two questions. The first one is, I like this idea of the kind of peer-to-peer internet. This is really great, and if you know the TV show Silicon Valley. The question is this PiperNet? And referencing the TV show there, they are far advanced to regular internet technologies. Could this be a goal? And the second question is, since you referenced PGP, there has been in the news something about a team of, I'm quoting, European security researchers has released a warning about a set of critical vulnerabilities discovered in PGP and SMIME encryption. You heard about this?
Yes. I'll answer that one first, because Silicon Valley is a little too close to reality for me. I don't really watch it. Yeah. As far as the recent vulnerabilities discovered in PGP, and I think you were accurate to say PGP MIME or SMIME, because it is about these kind of edge cases where you have very large files and attachments to whatever your PGP message is, and it can actually be any content type is one of the aspects of MIME, so it can be an executable. It can be any number of different malicious things. So it is possible to use PGP, particularly with some of these add-ons, as a vehicle of attack. is not, however, a flaw in PGP natively or doing more basic operations with it. For instance, signing a git commit, which is what we do, signing a block, it's not possible to embed anything in it that is not known and audible by all parties, right? Even automatically scannable. So you do have to be careful with PGP. It's not a panacea. However, our use case is perfectly safe. And in general, when you're looking at cryptographic systems, I think the most important thing is to not roll your own crypto. And the great thing about the PGP, the choice of using PGP, is how widely supported and standardized it is. There's over 10 or 20 hardware manufacturers, for instance. Ledger wallets already support PGP, as well as many wonderful applications and other parts of the ecosystem that are reviewed by literally thousands and thousands of developers.
One more question, please. Yeah.
Superficial question. Yeah, I tend to ask superficial questions, and this one is about the name. Well, how did you come across the name Guld? I have an idea, but I'd like to have it confirmed.
So it has a long storied history. As I mentioned, we've been working on this for a number of years. Originally, it was named Guld, and it was meant to be for project management or making DAOs on Git. And we built a prototype named Guld and started to reach out to developers, and particularly the team at Git. And we found out that they are basically controlled by the Free Software Conservancy, which is a somewhat hostile group, which made threats to us about the trademark Git. So rather than arguing with them or paying them some fees for trolling that wouldn't ultimately go to the Git developers, we just decided to rebrand. And I don't know if you know, we're in Germany, so it may be relevant. The origin of the word Guld is Geld, because the professional, which is gold in German, and the professionals of the guild would pay into a pot, a Geld, that would be like a fund for if one of them dies, they would take care of the widow or something like that. So basically, we just simplified it and went back to the roots, Guld.
Thank you very much.
Thank you.
Thank you.
Thank you.